Okay, so Unit 9 is solutions, and it'll be on your midterm, even though we haven't quite finished the content. So let's do some review. So remember, a solution is a homogeneous mixture, and so that means it all looks the same. So an example is an alloy. A metal alloy is just a mixture of metals. So for example, 10 karat gold is a mixture of gold and usually either zinc or copper. This is because gold is really, really soft. So if they mix it with copper or zinc or some other metal that's a little bit stronger, it gets the shiny, beautifulness of gold with the strength of the other metal. And that way your jewelry stays in the shape that it's supposed to. You can also have air, which is a mixture of nitrogen and carbon dioxide, and of course oxygen because we breathe it. There's some hydrogen and some helium and some dust and pollution. All of those things are mixed in the air. And you cannot decide just by looking in the air, oh, that's carbon dioxide, oh, that's oxygen. And so therefore it makes it a solution. A soda has water, there's sugar, um, there's carbon dioxide, right, which is the bubbles. Um, there's the little flavoring syrup. There's all kinds of things in soda. But when you look at a Dr. Pepper, it just kind of looks like a brownish black liquid. Um, which when you say it like that kind of sounds a little gross. But it's all there. And so a solution is made up of two parts, or two things, even if there are multiple things in there. You have your solute and your solvent. Now, the solute is being dissolved, okay? And so this is often your smaller portion, okay? Whatever is being dissolved is usually smaller than what it is being dissolved in. So the solvent is doing the dissolving. So for example, in soda, right, water would be your solvent, and the sugar and the carbon dioxide, those would be your solutes because they're being dissolved in the water. Now, water is called the universal solvent, and that is because it is uh, really good at dissolving things, pretty much everything for the most part, but it just needs a lot of time in order to do so. So yeah, universal solvent. So next couple things is we want to talk about, okay, well, if we know a solute and a solvent are involved in a solution, okay, how does the solute actually dissolve? Like, what's the process? And so the first thing is dissolution or dissociation, kind of get used interchangeably, but this means to break apart into ions. Or think about if you're hanging out with somebody who's not good for you, like you get in trouble every time you're hanging out with this person, you might need to dissociate yourself from them. That means you need to break up, you need to separate. Solvation means to be surrounded by water. And so some key things here is that if our solute is ionic, then it will undergo both dissolution and solvation. Okay, the ions will have to break apart and then they get surrounded by water. And if your solute is covalent, then it only undergoes solvation, where the water gets in between the molecules and breaks and separates them and surrounds them with water. Now, for this, for example, if I have salt, and let's say you've got two colors, okay? And we say that the green are positives and the pink are negatives, okay? If you have sugar, or excuse me, salt, then you have something that kind of looks like this, right? It's all together, there are lots of molecules, they're together, they're in a lattice, right? And then you add them to water. So you add H2O. And when you add H2O, what's going to happen is the water will separate your positives from your negatives. And the way that looks is you got to remember that this phrase like dissolves like. Okay, now water is polar. So remember, if you look at the structure of water, the Lewis structure, okay, oxygen has what we call a partially negative charge, okay, whereas the hydrogen are partially positive. Okay, this is because the oxygen is more electronegative, so it pulls the electrons that are being shared in the bond between hydrogen closer to itself. So that makes the hydrogens kind of positive and it kind of negative. And so when you have something that's positive and something that's negative being dissolved in it, it's very cool with that. But it means when water surrounds it, it will surround it in a particular way. So, for example, the positive ion will always have the negative oxygens pointed towards it. And that's because we know that opposites attract. And so with that theory, that means the hydrogens are going to want to be near something that is negative because they're positive and that's negative, and so opposites attract. And so they are prevented, the positive and negative ions, the pink and green, are prevented from getting to each other by the water. And so we'll see, it's kind of all separated, all of that nonsense. We could put like another pink one here, put another green one here, have some more waters, right? It just kind of all keeps going until every pink and green one from this is all separated and going on its merry little way, being dissolved. That's why it looks like salt disappears, because all of the particles separate so far that you can no longer see them with your eyes. Now, if a solute is covalent, so for example, if you have sugar, okay, sugar, which is C6H12O6, remember, if you're covalent, that means you're all nonmetals, right? And so that means you are on the left side of the periodic table, right around this way. And so C6H12O6, right, if you got some glucose, it's all nonmetals, carbon, hydrogen, oxygen, all nonmetals. And that means when you have it, so I'm just going to pretend one sugar molecule is an orange dot. So let's say you got a sugar cube. You got all of these little sugar molecules all together, okay? Well, when water comes in, the water will, will break up the orange pieces and surround them. But here's where it's different. It doesn't really matter how the water orients themselves, because remember, covalent compounds do not have charges. So the only thing that's happening is that the water is getting in the way and preventing the sugar from like rejoining or anything like that. But remember, each of those orange circles are 6 carbons and 12 hydrogens and 6 oxygens, and the orange circles are not breaking up. They're not breaking up into their elements. It's just happening where each individual molecule separates, but it itself does not break apart. So that is kind of a summary of the parts and what it means to really dissolve. So stay tuned for the next Unit 9 video.